Hey everyone, it's Mrs. Brimlow, and today we're going to explore what we call slope-intercept form. Now, before we do that, we need to do a quick recap of graphs and equations of proportional relationships. Please make sure you have a copy of these notes and you're copying everything down as you see it as I go through. And any questions you have, I'll be happy to answer when I see you again in class. So we have this example right here of a proportional relationship. Before we start talking about its equation and writing it, let's talk about what we see on this graph. So notice the title says bouncy house rental. So this graph is giving us information about how long and how much it costs to rent a bouncy house. Notice too that this is linear, so it has a constant rate, and it's starting at 0, 0, making it proportional. So that's really important because we know how to write equations for proportional relationships. That equation is going to look like y equals kx, where k is our unit rate, or we can now call it slope. So when I'm trying to find it on a graph, I know that I need to do rise over run. Before we dive into that, though, we need to check what are our increments on each axis. So for my x-axis, it's increasing by 1, whereas for my y-axis, notice it's counting by 100. Then it goes to 200. I left this blank just so I had enough space and the numbers weren't crunched, but I wanted you to see this was counting by 100. So 100, 200, this blank would be 3, 4, 5, so on and so forth. So when I'm moving up by 1, I'm really moving up by 100. So to get from this point to this point, or this point to this point, it doesn't matter which two you choose, I'm going up by 200 and over 1. So it costs $200 for 1 hour. Okay. So in my equation, this would be y equals 200x. So if I multiply 200, which is our unit rate or slope, by the number of hours that I rent this bouncy house, it's going to tell me how much it costs. So I can see if I make like a little XY table, right? If I don't rent it, then it costs me no money. If I rent it for 1 hour, it's going to cost me $200. If I rent this for 2 hours, it's going to cost me $400. If I rent it for 3 hours, it's going to cost me $600. And you can see how this is increasing by $200 for each hour. And I can see that on the graph, up 200 over 1, up 200 over 1. So that makes this equation y equal 200x. Okay. So now let's take a look at this next question. How would the graph and equation be affected if the company added an initial setup fee of $100? Well, it's still going to cost me $200 for each hour. So if I make a little table, so before I even rent it at all, I have a $100 fee. That's my initial fee to even rent it up. So they come and set it up for me. For 1 hour, it's going to cost me 200 plus that original sorry, let me say that again. For the first hour, it's going to cost me 200 plus the initial setup fee of 100 for a total of 300. If I rent it for 2 hours, well, I know for 2 hours up here it was 400, but I have to add an extra 100 for the setup fee. Okay. So I can see how it's still increasing by 200 each hour, except that I'm starting at 100 before I even pay for hours because that's how much it costs for them to come blow it up, set it up, do what they need to do. So if I go ahead and graph this, I'm going to see my first point is right here at 0, 100. My second point is at 1, 300. My next point is at 2, 500. And essentially, I'm just adding 200 for each hour. That's all I need to do. So 3 would bring me to 700 and 4 would bring me to 900. Okay. So I'm going to go ahead and draw a line through this. You might not have a ruler, So just use the side of a book, a folder, or just draw the best you can for now, okay? So if I think about this in equation form, this is still linear. It's still increasing at the rate of $200 per an hour. So what's different from this graph to this graph? Well, the difference is that my initial fee is $0. I don't have to pay anything for them to show up and give me the bounty house. Versus in this scenario, I actually have to add $100 initially in order for them to come and set it up. So notice I'm not starting at 0, I'm starting at 100 on the y-axis. So how that affects my equation is that I have to add 100 at the end. So the difference is that I have y equals 200x, and then here I have y equals 200x plus an additional fee, which I can see here is where this starts on the y-axis of my graph. So this right here is what we call slope-intercept form. So when I don't start at 0, I start at some other number on the y-axis. We call that our y-intercept, which is the 100 we see here, and we still have our slope, which is what we're increasing by that constant rate over time. So if you could flip to the back of your notes, we're going to summarize this and look at a few more examples. So once again, this is called slope-intercept form, where m is your slope or constant rate. That's not new. Really, the new piece that's new is your b, which is your y-intercept, where the graph hits the y-axis. So given this information, we're going to go ahead and write these as equations in slope-intercept form. So slope is -2 and a y-intercept of 5. So y equals -2x. We always multiply our slope by x. And then an intercept of 5, we're going to add 5. Okay. Number 2, slope is 3/4. Y-intercept is -3. So y equals 3/4 x. Now I'm going to pause here for a second. In the general formula, it says plus b. However, if your y-intercept is negative, you can write minus that number. So this would be y equals 3/4 x minus 3. So these equations are written in what we call slope-intercept form. The last thing we're going to go over today, which we've already started, is writing lines given a graph in slope-intercept form. So there's two pieces of information we need to write these equations. We need slope and we need y-intercept. So slope, we are experts at this point. I always count up or down first and then to the right. Here I need to go up, so I'm going to start at this point here. I'm going up 1, 2, 3, 4, and I'm going over 1, 2, 3. So I have a slope of 4/3. Now, y-intercept, once again, is where it's hitting the y-axis, not necessarily through the origin. And in this graph, that would be at this point, which is 0, -5. So if I put this all together for an equation for this graph, it would be y equals 4/3 x. Now my y-intercept is always the y value because x is always 0. You're not moving left or right. Your y-axis, you're going up or down. So it's going to be -5 in this case. So I can see based on the slope-intercept form, -5 is my y-intercept where it hits the y-axis. My slope is up 4/3, which is how this graph is changing over time, the rate. Okay. So we're going to try this last graph, and then you're going to go ahead and practice. So notice that this has a negative slope. So right away, I know this is moving down. So I count 1, 2 down. So I'm aligned with my next point, and I'm going to go over 1, 2, 3, 4. So -2/4, which I can simplify to -1/2. When you can simplify but leave it as a fraction, you should. Let's say I got 7/4, you would leave that as is. But if I have anything to simplify, I should. And if I go back to this graph, starting at this point, if I go down 1 and over 2, notice it does take me to this point that's on the graph. It's just not the one they gave us to use, and that's okay. It's just proving that that slope is -1/2 or 1/2. So my y-intercept where this graph hits the y-axis is at the point 0, 1. So altogether as an equation, this is y equals negative 1/2 x plus 1. Okay. So once again, in this lesson, we've learned what slope-intercept form is as an equation made up of slope and y-intercept, as well as x and y are independent and dependent variables. We learned how to write that given information or given a graph. If you have questions, please feel free to ask when I return to class. At this point, if I am absent for this video and you're watching, then you can see the sub for notes, a practice sheet, or you can continue to iExcel. And once again, I will answer questions when I return. If you're at home watching this, then you can ask questions when you return. And I will see you all soon.